Hello, ladies and gentlemen. So today we're going to be doing a demo. I have a marble in my hand. It's just a small marble. That's a cat eye or tiger eye marble, whatever it's called. And I'm going to be rolling it from the top of this foot-long ruler. It has kind of a groove into it. It's going to be going down, and it's marked at the 20 centimeter point on these 2 meter sticks. So it's at the same distance every single time. And I want you to before you make a prediction, I'm going to be rolling this marble, and every time I go through, I'm going to be doing 3 trials of it. I'm going to be timing it as well, and you won't see me time them, but know that I did, and I'll show you the data at the end. And every time I roll them, I'm going to be adding one of these books over to this side, and so the height is going to increase that it's being rolled on. And so I want you to make a prediction before I do this that you can see on the screen right now. So answer that prediction. Now that you've made the prediction, I'm going to go ahead and do it. So again, I have 1 centimeter that's just lipped over the book right here, and then this foot-long ruler empties into this track right here at the 20 centimeter mark for both of the meter sticks. So it's even on both sides, and this is just so that the marble doesn't roll away. So here we go. Okay, that was the first book. Second book. Third book. Fourth book. And last book. So I have all of the data for the trials here. You can see trial 1, trial 2, trial 3. These are all in seconds. And then we have 1 book, 2 book, 3 book, 4 book, 5 book. So this is all the data that I've collected. And then here is the average time down below. And so what I would like you to do next, remember that these marbles have traveled a distance of total distance traveled. They have traveled a distance of 0.8 meters. And so this is going to be consistent for all the trials. And so your next thing to do would be to take these, take each book, so take each of these average times here, and take the total distance that they've all traveled as well. And I want you to make a distance versus time graph. So that means that your distance is going to be on the y-axis, and your time is going to be on the x, or the horizontal axis. And so you'll have to make a key for each of these books here. So you have, or excuse me, each of these times. So you have book 1, maybe or on your x-axis, you would go 1.8, I guess, units or seconds over, and then you go up 0.8 or 0.8, and that's where your first stop would be. Remember that everything starts at 0, like the time is 0 and the distance is 0. It hasn't gone anywhere yet. And so that means that our total distance covered is 0.8, or excuse me, our starting distance is 0, and our starting time is 0. So everything's going to start at the origin, or where the x and the y intercept, right here. So you'll do that for book 1, you'll do that for book 2, and you'll do it for book 3, you'll do it for book 4, or 4 books, and you'll do it for 5 books too. And so that's your next task, is to create what that graph might look like. And so go ahead and do that now. now that you've made that graph, I will show you the one that I came up with. So here is using all that data. Again, this was the average times. So you have here are my units. It's in meters, or a lowercase m is the scientific or the SI unit there, or the notation, I suppose. And then you have time on our x-axis. Time is usually always going to be on the x-axis. There's some instances where it's not, but basically everything that we do, or everything that we do in this class, is going to have time on the x-axis. So you can pretty much guarantee that that's going to happen. So it's also in seconds, which is also the abbreviation of SEC. So here's my units going across, and as you can see, one book is right here. 2 books is this blue line. 3 books is the green line. 4 books is my red line, and 5 books is my yellow line. And so I'd like you to just take a moment and come up with a answer to the question that is on your screen now. Okay, so the next thing that we're going to be talking about is how do you actually calculate velocity on these things? And so I'm going to make a quick text box over on this side here. And I'm going to put a backfill in. And I'm going to make it bigger. But I'm going to make this font smaller. So the way that we calculate velocity is equal to distance divided by time. And so all we pretty much have to do is just take those numbers that we had in there. So for instance, if I come back and look at the data for book number 1, or for one book, velocity is going to be, I come over here, I look at the average time, which is 1.8, and the distance, which was 0.8 meters. So to find the velocity for this, I'm going to put v is equal to the distance, 0.8 meters, divided by 1.81 seconds. And so if I do quick math on my calculator, we have 0.8 divided by 1.81 seconds. That's going to give me a velocity of 0.44 meters per second. And that's the scientific, or the SI unit for velocity. So this is going to be our velocity here. Can I highlight things in this? What's this? Oh, I totally can. Nice. So that's our velocity for the book 1. And so you can go ahead and fill in the fill in the velocities for book 2, book 3, book 4, and 5 books. So all the other ones in the prompt right here. And lastly, the next thing that I want us to notice is the distance. So what do you notice about the distance between here to here, the blue line to the green line, where they end anyway, like where these dots are, the green line to the red line, and then the red line to the yellow line? So go ahead and answer that in the prompt that's on the screen now. Okay, now that you've answered that prompt, this is called the acceleration. And so we know the acceleration is like when I drop something, like for instance, if I have that marble, like so, I have this marble. If I drop it from right here, not very high up from the table, it's not going to end up going very fast. But if I drop it from really high up, it's going to have more time to accelerate or to speed up. And so that's basically what we see here, is the more the more vertical that ramp is, the more of a jump initially there is on the speed. And so this would be a really large gap, or a really large jump in acceleration. So the acceleration goes up really fast at the beginning. But as it goes up towards 5 books, and if we did like through 10 books and it's almost vertical, we would see that these lines basically become straight up and down, or excuse me, like overlapping of each other. Like the difference that we see over here is going to be way less than what we would see over on this first initial step up. And so that deals with something with like gravity, and you'll talk a little bit about that uh, in high school. But it's something called a quadratic formula, or not quadratic, excuse me, a quadratic equation. So it's to the power of two. So every time like the velocity, or excuse me, it's like the velocity divided by the time again. So it's meters per second, and that gives you the acceleration. So that's why it's like kind of a, if you were to graph the velocity, it would actually be kind of like an arc rather than just like straight lines, what we see here. The line would actually start at 0 and it kind of like follow my cursor and eventually just taper off towards 9.81 meters per second, because that's how fast our gravity is. If we were on Saturn or something, then that graph would wrap a lot faster and it would come a lot closer to, I don't know what the gravitational pull of Saturn is, but it's a lot more than on Earth. And if we were on the moon, then that curve of, or that difference between these ones here would be a lot more similar, because there's less gravity on Earth or on the moon as there is on Earth, and so these differences would be pretty much the same. If again we were on Saturn, these differences would be very, very tight together. And so this like distance that we have here equates to the acceleration that that marble is going through. And in this case, that acceleration was from gravity. So yeah.